right, welcome back, and let's see if we can knock out some more of this review test. So find the 5-number summary of the sorted data in a graph. It's box plot. So again, it's sorted, so it's already numerical order, so that's good. So now we just need to find our 5-number summary. So what is in your 5-number summary? Well, 5 things. So we got our max and min. Let me start with the min and our max. So our min is 4. Our max is 63. So now the 3 in the middle, remember, are your 3 quartiles. So your Q1, Q2, and Q3. Now Q1 is based off of the 25th percentile. So you're 25% of the way through the list. So you had 25 over 100 times 1, 2, 3, 4, 5, 6, 7, 8, 9. So 18. So there's 18 numbers. So if we take 25% of 18, that would be 4.5. So actually, I'm going to go underneath here. And now, because L is a decimal, we know that we should round it up. So it's going to be to the 5th. So the 5th value in the list, so 1, 2, 3, 4, 5, so that's a 14. Okay, Q2 is based off of an L of 50. And so that's going to be a 9. Now, remember, when it's a whole number, we have to look at that value and the next. So we want to look at the 9th and the 10th. So the 9th is an 18, the 10th is an 18. So they happen to be the same value, which is fine. So that just means that it's going to be 18 because we're going to add those two and divide it by 2. So we're back to 18. All right. And then Q3, so it should be off of 75, 75th percentile. So that looks like it's going to be a 13.5, which will round to the 14th value. So 18, 17, 16, 15, 14 would be a 32. All right, so we have all of our 5-number summary. So now we got to put them into a box plot. So first thing we got to do is get a good scale across the bottom that encompasses all of our 5-number summary. So we got to go from 4 to 63. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we got 12 dashes. 12 goes into 63, 60-ish, 5 times. So if we go by 5s, maybe by 6s, just to make sure we have enough. So let's start at 0, and we'll go by 6s. Now, like I said, you can go by 5s, but you might be a little bit, scrunched on the edges. So doesn't hurt to be a little bit big, but not, you don't want to get too crazy big. So, all right, so we got plenty of room. We're not too far beyond our max and min, so that's a good thing. So we should be able to put everything in here now. So 4 is the min. So looks like if we go by 2s, 2, 4, 6, so we need to go about 2/3 of the way through to get to a 4. So probably right about in here. Now I like to label it up above, but it's not required. It just helps you kind of confirm that your number is where it's located. All right, the next quartile is 14. So again, let's go 1/3 of the way through. And then we got 18, so that's right on the line. Then we got a 32, which is, again, is going to be about 1/3 of the way through. And then we got 63, which is going to be right smack dab in the middle between 60 and 66. So that's step 1. Get all of your 5 numbers identified on your grid, and now you can make your box plot. So the next step is just to get that line right down the middle And then we got to connect the 3 in the middle on the top and the 3 in the middle on the bottom. And so that is your box plot. Not much to it. All right. So now we got a frequency distribution, and we need to find the mean and standard deviation. Fun, fun, fun. Well, the first thing we should probably do is make sure we know what our titles in our table should be. So your first is going to be X, because remember, we need a representative value from each of your different classes. So the midpoint is going to be that representative value. Next, we need to multiply by the frequency. Then we want to square those values of X. And then we want to multiply the frequency times that squared value of X. So there's your headings. And so now we can just got to fill everything in. So 40 to 49. If we average that, 89, so 44.5. And now if we look at our class width, which we can see is 10, we can just add 10 all the way down. Now, as simple as that is, it's very easy to make a mistake. So just don't go too fast and make a writing error in there. So, and like I said, if you wanted to double check the last one just to make sure the answer is right, that you added correctly, it doesn't hurt to do that. All right, so now we got to do some multiplying. So we're going to pull out our calculator here. Well, 1 times that, I think we can do without 1. 4 times that, well, let's just be safe. So 218. 2 times that, well, 129 probably. Okay. 6 times that, 447. 3 times 85, 4.5. 253.5, and 2 times that looks like 189. Okay, so there's that. Now we got to square all those values. So 44.5 squared. Now the numbers can get big, obviously, so just, try to space it and all that good stuff. Okay. So far, so good. Now you can kind of see the ending is all going to be 0.25. So if you want to fill those in, that would be fine. So 84.5 squared. And I'm going to guess this is a 30 something. So 94.5 equals, oops, squared, 89, 30. All right, so now we have all of those filled in. So next is we got to multiply. Again, be very careful which columns you're grabbing. So we need the frequencies times this column to fill in this column. So since I got that one in there, I'm just going to multiply that by 2. So 17,860.5. Okay, 7140.25 times 3. So it looks like 21,420.75. 5550.25 times 6. 33301.5 and 4160.25 times 2. 8,320.5. 2970.25 times 4. 11,881, and 1 times that, which is 1980.25. Okay, so you got the table completely filled in. Now, if we were just finding the mean, we really don't need all this table. We only need these first two columns. So how do we find the mean now that we have this table all populated? There's two columns that we need to add up. Which two columns are those? Now, the little trick with this that I would try to stick in your brain is only add up the columns that have an F in them. So this is an F column. Here's another one, and here's another one. So all three of those we're going to need to answer these two questions. So let's add up all of this. So it looks like we got 5 and 8 is 13, 13, 14, 15, 16, 17, 18. So we got 18 numbers here. So that's how many data values we're actually dealing with. We got to add up this column. So let's do that. 44.5 plus 218 plus 129 plus 447 plus 253.5 plus 189 equals, so 1281. All right. Now, again, we don't need this stuff to answer the mean question. So we just need these two values, and we're really home free at this point. So if we divide that by 18, we get 71.16. 6666. Whoops. 71.1666. Now, rounding. Well, what should we round it to? Now, all of our data based off of these different classes would say that our data are whole numbers. So we really only need one decimal point. But as I said before, if you want to use extra decimal points, you can. Just make sure you round properly. So I would accept one of two answers. You could say 71.2 millimeters, or you would say 71.17 millimeters, because that would round properly. So either one of those would be acceptable. Now, how do we know we're right? Well, look at your data. Your smallest value is potentially 40, and your largest is potentially 99. The bulk of your data is kind of floating around this interval, this class right here, because there's 6 of them. So, and look at, our mean is right in the middle. Well, it's closer to the 70, which is fine, but it's in this interval. It's in that class. So we're probably on the right track. So we're probably good. Now, to answer number 12, we're going to have to add up this column here. So let's do that real quick. So 1980.25 plus 11881 plus 8320.5 plus 33301.5 plus 21420.75 plus 17860.5 equals. So 94764.5. Now, we need these two sums. So if we're going to figure out these two sums, we got to know what this is adding up. So f times x squared. So that is the column name. So all they want you to do is add up this column, which we just did. So that is the first sum. Now for the second one, it's a little bit confusing because you got all the brackets and stuff like that, but they want you to add up the f times x column and then square it. And we already added up the f times x column. So all you need to do is take this 1281 and square it. So 1281 squared is 1640961. So that will give you that sum. So if we put this information all into our standard deviation formula now, we should be able to wrap this up. So we got S is equal to the square root of Now our n in this case is 18. So we got 94,764.5 minus, I'll squeeze it down below, all over 18 times 18 minus 1. All right, so let's get our calculator out here. So if we got 18 times 94,764.5, that gives you that. Let's subtract the 164,0961, gives you that. And so 64,800 divided by 18 times 17 equals 306. So now if we divide those, 64,800 divided by 306 equals 21, oops, a little bit off the screen here, helps if you can see it, 211.7647, so on, and then we got to square root it. So 14.55. 213. Now again, rounding, make sure you use an appropriate number of decimal places. If you want to use 1 or 2, that would be acceptable based off of your, again, your data is going to be whole numbers. So 1 or 2 decimal places, so either 14.6 or 14.55 millimeters. And that would be your answer. All right, so that wraps up this page. We'll see you in the next one.